Oh, hello. I'm so sorry. Good evening, guys. Actually, I was talking, but the mic was going against me. So you should tell this to the mic rather than me. Okay? I'm so sorry. Okay, so let's welcome back to the IOQM session. And yes, so we will start with the first problem of today. The first problem focuses on the aspect of combinatorics. Okay? It's a very easy problem, guys. But we will do this. So we will slowly build up the momentum of the problem with the difficulty level. And let's start with a really easy problem. Good evening. Yeah. So the first problem of today. So there are 5 CDs. Okay. And the 5 CDs are connected to each other via these roads as they are being shown. Okay. And okay. So the routes are being shown here. Hello, good evening, Tishika. The routes are being shown here, and the question solves that how many, like question asks is solved on how many different routes are there from A to B that use each of the road exactly once. Okay. The question revolves around the fact that how many routes are there from A to B. So let's mark it here. How many routes are there from A to B? Okay. Which goes through exactly all the routes exactly once. Okay, all the roads exactly once, not the routes. I'm so sorry for the nomenclature. Which goes through all the routes again, sorry, roads for exactly once. Okay, all such routes. How many routes are possible? Okay. So good evening all of you. Hi Ahana. So yeah, that's a problem. And let's focus on, so in the history of this combinatorics, this is called Eulerian routes. And why Eulerian routes? Because it's a Königsberg problem, which is the beginning of graph theory, which focus on this type of exactly once. Okay, we must cover the road exactly once. Okay, so yeah, so I will give you a few minutes to think about. Yeah, sure. For example, let's take a route. Okay, let's take a route. Let's take this route. So this is a route. Okay, a bad one. I think this is a route. Okay, this is not a route. I'm sorry. Yeah, हुआ है. Yes. Yeah. Then this, then this, then this, then this. Okay. So one of the routes is one of the route may be like this. Okay. Okay. So now what we will do is that we will count all the possible such routes that are possible from A to B with exactly one such, taking exactly each road exactly once. I hope all of you understood the problem, guys. Amit, I explain the problem for you. So A, B, C, D, E are 5 cities that are connected by the roads as shown. So how many routes are there from A to B that use the roads exactly once? Okay? 1, 2, 3, 4, 5, 6, 7. This is one road link. Okay, guys? Okay, so let's focus on now. So do you want me to give you some time to think about this? Ahana, Tishika, did you understand the problem? Iron is here. C and E will not make a difference while counting. Okay, let's rub this off since I've already got the example over here. Let's rub this off and go back to the initial problem. So what we have over here is that we have these two cities A and B, and we must go from A to B in some sense which covers the road exactly once. Okay, that's the idea. Still not clear? So we have to take the roads such that we cover each of the roads exactly once. Okay, for example, this road is not possible. This one you can go and come back, and then again go back, and then come back again to B, right? So repeating one road is not allowed. Okay, repeating one road is not allowed. Okay, so I will give you few minutes to think about it, and I am starting the countdown. Okay, on the background. No, don't think in a very so complicated way. Think in a very easy manner, guys. Okay, think in a very easy manner. I've created the timer for your own. Yeah, as well. Sure, they can be straight as well. So, as Kanishk has told, the C and E doesn't really make a difference. Okay, the C and E doesn't really make a difference. Okay, what's on your mind, guys? I gave the countdown for you to think, guys. I gave 30 minutes countdown for you to think. Okay. So yeah, so what Kanishk, what did you tell? Kanishk, what did you tell? Can you tell your idea once again to all the people out here? So observe the first hint, guys. Suppose you go into C, okay, or E. If you go into C or E, since you cannot trace back the path, there is only one way to go through E and C, okay? So either you go this way or that way. You understand? There is only one way to go through C, like this or like this. So essentially, you can rub off this A, this E and C. These are redundant over here, okay? There's only one way out there. So it's like this. You can sort of draw like this. Sort of. So this is a renewed path. Okay, this is a changed path. So there is D here, there is A here, there is B here, and one can go along this, one can go along this, one can go along this, and C can essentially, C is over here. Essentially, it's one path only because it can only traverse exactly along this path. Okay, there is no other way out for C and E. Okay, all of you understood this? This is the first important step. Okay, this is the first important step, and then what's next? I think Kanishk already told this. Yes, you're right, Sauradip also. Degree of C and E are both 2, therefore we are only considering only the path, only single path through C and E. Perfect. Now let's count on this new wala path, okay? On this new wala path. How many possibilities are there? 5 is not the answer. Amit Malik, you are in which class? I think this is the most easiest problem that you can do. That I think you have to practice more and come. Okay. I mean, this is a like live session. I cannot really focus too much on. Yeah. Anyways, I hope you understand. Okay. So I hope all of you understood it. So what's the next step, guys? The next step is counting the stuff. 5 is not the answer. Those who have told 5. Now observe very carefully, guys. What's next? We should focus on now counting this. So let's start counting this. How will you start to count? No, we have to do some casework. You have to understand it. You have to do some casework over here. So what are the casework that can happen? So we can do it in 2 steps, okay? We can travel from A to D or D to A. Similarly, we can travel from B to D and D to B, okay? A to D and D to A, and B to D and D to B, okay? B to D and D to B. So essentially, let's consider case 1 where we are moving from A to D. Okay, let's fix one of the path. Okay. If you fix one of the path, then what will happen? You move along this path. So we are fixing one of the paths, okay? We're moving along this. Okay. And it can happen that from D it can come back, right? Right? All of you understanding it? If it's come back, then my A must go to B, right? And then it must go here and come back. So try to observe this very carefully. Try to understand the cases over here, okay? So we have A over here, we have B over here, we have D over here. Okay, there are 2 paths from here to here, here to here, and here, okay? So suppose A goes in this path, that comes back in this path, okay? Then it is only this way out there, okay? Okay? So A to D, then to A, then to B, then to D, then to B. Okay? Now this has 2 different possibilities, okay? 2 different possibilities here, and here 2 different possibilities. So therefore 2 into 2. Why? Because one can go like this and this, come back again. So 2 paths for here and 2 paths for here. So total number of 4 possibilities out here. Okay? Total number of 4 possibilities out here. Yeah, right. No, via this route, if we follow this algorithm of path, then the 4 possibilities out here, okay? Then so first step, A can go from where? A can go to D or B, right? So we are assuming the case that A is going to D and then going to, again coming back to A. So A can go to D, again come back to A can go to D and then go to B, right? Or what can happen? A can go to B directly. A can go to D, try to understand, A can go to D and then come back to A can go to D and go to B, and A can go to B and cannot come back to A because there is no other path, so it must go to D then, okay? So these are possible paths that can occur from A. Okay? Try to understand this very carefully. Exactly. So I will write this down again in details over here. Try to observe the path. A can go to, so what I did above is an example, okay, how you should approach the problem. A can go to D and then to B. A can go to D and then to A. A can go to B and the paths possible. Okay? Now if A goes to D and then to B, Okay, it has two paths over here, two possible paths for going to D to B. Now, if it goes to D, okay, let's try to follow the path now. A goes to B and then B to B. Then what can happen? Then there are only two paths. B, A, D, B, or what? Or B, D, A, B. Okay. Now let's see this. A to D, and we have done this above. It's go to B, D, and B. And let's do this here. For this case, A to B, okay, and then it goes to D. It's again symmetric like above, okay? A to B, and then go to D for. If it goes to D, then there are two options. It can come back to B, but it cannot come back to B because there is no other way out. We already traversed the route A, B, so it must come back to A. B must come back to A. Okay? And A must again go back to D and then must come back to B because AB is already done. So there are these four possible ways of moving, right? All of you understood this, guys? There is four possible ways of moving, exactly covering once. I'm repeating once again, guys. Tishika, did you understand? Ahana, Sauradip, Kanishk, Ramakrishna, Raghav, Srijit, Olivia, Ritik. Okay. I hope all of you are Rajvardhan. I hope you're understanding. So let's try to understand it again. So one starts from A, right? From A, one can go to two places, either D or B, because we have seen that going through C and E are the same. It's like joining the road. So it goes to D. And if it goes to D, then it can come back to A or B, right? And if it goes to B, it can go to D, okay? And let's see what can happen. So if it goes to A to D, from here, say, somewhere here, and D say it can come back, suppose it's go along this way, and B say it can go to B, I can follow A like this, okay? Or B, it can go to B and then it can go back to D and then A and then B, okay? So these four possible paths are there. So try to observe that where there are multiplicities. From A to D there are two, okay? From B to 1 there is D to B, there are two possible paths, and if there is 2, then the rest is fixed, right? So the here it is 4. Here let's see. Here A to D, how many paths are there? 2 paths are there. D to A, only 1 path is there. A to B, 1 path is there left, and B to D, 2 paths are there. D to B, 1 path is there. So here also 4. And here, okay, we didn't see this way out, sorry. It was for this, actually, this road. For here again, it's 1, 1. So it's 4 over here. And here A to B, how many paths? 1 path. B to D, 2 paths. D to A, 2 paths. A to D, 1 and 1. So essentially 4. Total number of ways are 16, therefore. All of you understood it? It's a very easy problem. It can also be done in a following manner. Since all of them are covering exactly one road, and we have 4 such roads, right? 4 distinct roads. 4 distinct roads are there. We have counted, and each one of them can be covered in exactly 4 ways. Since it's going through 3 cities and 2 cities are like 2 roads are there for between 2 cities, okay? And therefore it's summing up to 16. Okay, it's really interesting problem, guys. Okay, and okay, so let's move ahead to the next problem. I hope everyone is clear with this. Any doubts? There are exactly 4 distinct paths. I mean 4 paths in terms of CT, via CTs, and via CTs there are two paths. So essentially 16 different paths are there. Okay. Okay, let's move on to the next problem. I've already done the next problem over here. Okay. So problem number 2. Yeah, the answer is 16. So 2013 is expressed in the form this: a1 factorial into a2 factorial dot am factorial by b1 factorial into b2 factorial dot bn factorial. Okay, where ai is greater than equal to, like, ai is decreasing, is decreasing, and bi is also decreasing, such that a1 plus b1 is as small as possible. What is a modulus of a1 minus b1? Okay, what is the modulus of a1 minus b1? So let's try to understand this. 2013 is expressed in a1 factorial into a2 factorial or am factorial by b1 factorial into b2 factorial or bn factorial. Okay. Now don't get carried away by these things, Ramakrishna, because these are simple problems. Okay. The best beautiful part of mathematics is being simple, even in life as a human being and even in mathematics. Okay. You should be simple as simple as possible, because you need a minimum number of things to, like, if you apply simpler methods, na, you have minimum arsenals. So that's the beauty. Okay, so people are asking me to factorize. So that's the first hint. Okay, that's a good hint to factorize. That's a very good hint. Factorize 2013. Why did he think of factorization? Kanishk thought because it is of the multiplicative form, right? So therefore it's urging us, okay, it's forcing us to factorize it and then compare both the sides. So therefore factorize 2013. And 2013 is what? It's exactly equal to 61, as Kanishk has told, into 11 into 3. Right, guys? Only 3 factors. So what is written over here? Therefore b1 factorial into b2 factorial dot bn factorial is into 61 into 11 into 3 is equal to a1 factorial into a2 factorial dot am factorial. Okay, we know the result. Now let's try to compare this AIs and BIs with the given results, given factors rather, okay, given numbers. Okay? So I will give you 30 seconds to think about it. Sauradev will again tell why there is a 30-second break. It's not a break, it's for you to think. Okay? I hope you have written down the thing in your copy, the question in your copy. So I will give you 30 seconds to think. So there is another 30-second timer coming up. Okay, I hope you have thought about the problem, guys. And let's now try to factorize it and make the full use of the factorization. And what we'll use, it's called fundamental theorem of arithmetic, that it can be broken down into factors. Fundamental theorem of arithmetic in prime factors. Yeah, we used it, so now we have to compute this. So let's try to understand, compute. So 61 is there, right? So 61 somewhere will be the prime, right? 11 is also a prime. So it must somewhere be there inside this, right? On the right hand side. So sum of the AI must be greater than or equal to 61. Right, guys? So one of the AIs must be greater than equal to 61, right, guys? What is the answer? The answer, I will not tell you what is the answer. The answer is not okay. The answer is not really 1, but you are close to it. Okay, so how will you approach this problem now? How will you think about this problem now? So one of the AIs must be greater than 61. Okay? What's next? What's next, guys? What do you think? What's on your mind? What did you do in 30 seconds? Kanishk, Raghav. Since we have to minimize the result, yes. So we have to minimize A1 plus B1, the minimum of them as small as possible, okay? But there is no upper bound on the maximum. No, don't give us blank gazes. Just try to solve the problem. No, it's a mathematical problem given. Why it's 1? Because 1 is a minimum natural number. Think about it. What do you think? Okay. But why do you think so, Aryan? I mean, why is A1 61? That's what I want to know. That's what I want to know. Why is A1 61? Not something else. Why is A1 61 and not something else? That's my question. Why you're assuming A1 to be 61? Yeah? What do you think, guys? Tell me. Yeah, so if we need to minimize, why don't we hold? Yes, perfect. Oh, I forgot. I'm so sorry. Yes, you're right. So we need to minimize it, right? So therefore, an AI is a maximum of all, okay? Yeah, I made a mistake in my thoughts. I was thinking AI was the minimum. A1 is the minimum. So yeah, so essentially A1 is the maximum of all of them. So A1 cannot, so essentially what can happen that A1 must be equal to 61, okay? There is no other possible choice. Okay. A1 must be 61 because A1 is the maximum of all and 61 must be a factor on the right hand side and 61 is a prime. So it cannot be mixed up to make up 61. 61 must be there as a whole in the factorial, okay? So A1 must be 61. That's it. So A1 is 61. Okay, let's focus. A1 is 61. So we have done that A1 is equal to 61 factorial. Okay? So what do we get over here? We get B1 factorial, B2 factorial, Bn factorial is equal into 11 into 3 is equal to 60 factorial times A2 factorial, Am factorial. Okay? Oh, why not greater than 61? Because if there is greater than 60, oh yeah, why not greater than 61? That's a very good question. Why not greater than 61? Yeah, why not greater than 61? Because we are trying to minimize A1 plus B1, okay? So if we take 62, it can happen. But let's take the minimum possible case. Okay. If there is no solution, we will move on to 62. It's sort of a hit and trial method. Okay. We're sort of seeing it. Okay. So we are taking the minimum possible value of A1 plus B1. Okay. But it can be 62. That's very, very rightly pointed out. But we first do with the minimum case. We explore it. And then if it doesn't work out, then we'll go into 62. Okay. We'll move on to 62. Okay. Yeah, so this is 61. What's the next step? Do it mathematically, guys. 11 into 3. No guesswork, mathematically. What's next? What will you do next? Remember, B1 is greater than equal to B2 is greater than equal to Bn, okay? And everything is greater. So people are telling that B1 can be 60, okay? But can't B1 be less than 60? Can't B1 be less than 60? Yeah, what do you think, guys? What do you think? B1, okay, there are two possible choices, okay? So B1 can be 6, can B1 be 60? Or does there exist a better choice of B1? Because we are trying to minimize A1 plus B1. So if we can minimize A1 plus B1, B1 can be less than, right? So can we get a better choice of 60? So what is the highest prime that can occur over here? Before 60, it is 59, right? So 59 is here somewhere. It's sort of, you can write it as 59 factorial times A2 factorial dot AM factorial times 60 is equal to B1 factorial, B2 factorial dot Bn factorial times 33. Right? Now B1 must be greater than equal to 51, right? You can understand it from here. B1 must be greater than equal to 51 because it's a prime. The 60 can cancel out by other factors. Okay? And B1 must be greater than equal to 51 and B1 must be less than equal to 60. So there are two possible choices of B1. 59 or 60. Okay? So since we are minimizing A1 plus B1, we have taken A1 is greater than equal to 61, we have taken A1 to be 61 and checking. Okay, and since B1 is greater than equal to 59 and 60, so let's assume that B1 is equal to 59, okay, assume. So we are taking the minimum possible choice and let's see whether it works out or not. Okay, it's a hit and trial and exam, like it's taking and seeing, okay, that's a very important problem solving aspect of mathematics. So it's 59 factorial times B2, or Bn. 33 is equal to 59. So 59 gets cancelled out. Okay, what's replaced next? A2 dot AM times 60. Okay. Now, is there a solution to this? How can you find a solution to this? So I'm doing more than the problem, whether there is a solution to this or not. If there is no solution, how can we do it? Rather, can we express a solution in this manner? So we have got B2 factorial into dot Bn factorial into 33 is into is A2 factorial dot Am factorial into 60. Is there a solution to this? No. Okay. So essentially, what's the idea is that why 59? Because 59, because suppose we take it to be 60, okay? Suppose we take it to be 60. So essentially what we're trying to minimize, we're trying to minimize A1 plus B1, right? And we have shown that A1 is at least 61 and B1 is at least 59 and less than equal to 60, okay? Right, that's it. So if B is at least 59 and less than equal to 60, and since we're trying to minimize A1 plus B1, Okay, so therefore we are taking the option of B1 is equal to 59. Oh, why not 58? Because B1 is a maximum right here again, right? And 59 is a prime number, right? So therefore, what will happen if 59 is a prime number? I mean, B1 has to be 59 by the exact same logic. Why A1 has to be 61, right, Rajvardhan? Right, guys? I hope all of you understood that. Yeah, so we will essentially divide both side by 3. So what we will get? We will get 11 over here and 20 over here, right? Right? So that's an interesting aspect. So can you solve that? Kanishk has already pointed out. Yeah, these are the expected type of problems you can expect in IOQM, okay? The difficulty levels are also same. Okay, I hope all of you understood it. So now we will see what is a possible solution. Okay? So now observe that, so as Kanishk has told, there is a factorization like this. Okay, what is the factorization? If you do hit and trial method, you will see the factorization coming over here. Okay, so that is the factorization that Kanishk has told, that is 61 factorial. So what we have got A1 to be 61, right? Presume rather, and B1 to be 59. So we are what we are trying to do. We are trying to do is like sort of do 61 times 11 times 3 is equal to what? Is equal to 61 factorial times whatever is there. And we have Nietzsche, we have 59 factorial and whatever is coming up over here. So we have got from here, we have cancelled 61. Okay, so we have got that we have 11 into 3 is equal to 60, right? 61 is cancelled, yeah. Into something over here, some factorization over here, and some factors over here. Okay, so we have got another 20 over here. Okay, if you have got another 20 over here, so what's a possible choice? That yes, and almost done. Yes, so if it's 20 over here, what we can do is the following. We can take 19 factorial over here, if 10, that is 19 factorial over here, and we get 20 over here. Okay, sorry, not 20. What I am doing, I'm so sorry. Okay, so we multiply 19 factorial over upper niche, okay, up and down, and what do we get? We get 20 factorial by 19 factorial. Or do we? Where did this 11 go? Can someone tell me? Where did this 11 go? Yep, where did this 11 go? So we have to bring in some 11 factorial, right, to make use of that 11, right? So 20 is over here. So we have to make use of that 11. If we take 11 out here, 11 will get cancelled. We have 10 factorial. We have 10 factorial over here. And if we do 19 over here, it will be 19 factorial. So essentially it will be 20 factorial by 11 factorial by 19 factorial by 10 factorial. Okay? So any number can actually be written by n factorial by n minus 1 factorial. So essentially we are using that property. Okay? That's it. We're using that property that any number n can be written by n factorial by n minus 1 factorial. So that's a property we are using over here. Okay? Fine. Very good. So all of you understood the problem, guys? May I move to the last problem of today? Okay? Good. So let's move on to the last problem. Okay, so there are two problems. Okay, only one problem is there. So let's. Oops. My computer hanged. Let's wait for it to. Okay, so it's an algebra problem. And if you can complete it together first, then we can move on to other problems. But what did happen to my laptop? It froze. Yeah, it came back again. What is the software usage? It's called Google Jamboard. Yes, it's really beautiful, but it takes a bit of time to like correspondingly adjust with it. Okay, so yeah, hit and try, but there's a logic, Rajvardhan. Okay, that's the beauty of problem solving. Okay, by the way, Ahana and Tishika, are you understanding? Ayan Khan, are you understanding? If you're here. Okay, so let's focus on this problem. A, B, C are real numbers such that, see, it's a theory of equations problem, okay? A, B, C are algebra problem rather. So one combinatorics problem, one number theory problem, and one algebra problem. A, B, C are real numbers such that A plus B plus C is equal to 2. And A square plus B square plus C square is equal to 12. So what is the maximum possible values of C that can, what is the difference between maximum and minimum possible values of C, okay? That's the problem. So how do you approach a problem? So it's a very easy problem to understand mathematically. So do you need this 30 minutes of thinking time now? Yeah, the previous answer was 2. You're right, Tishika. Okay, so the first hint has come from the people that we have to do squares, okay? I mean, we may have to do squares. I'm not sure about it. Let's see where it goes, where the flow takes us. A plus B plus C whole square is equal to 4. Why did he do that? I guess he did that because he wants to get the value of AB plus BC plus AC. So therefore, and we have A square plus B square plus C square. Therefore, we have got AB plus BC plus AC is equal to what? Is equal to 4 minus 12 by 2, right? 4 minus 12 by 2, that is minus 4. Perfect. Four minus 4, okay? Perfect. So now what's next, guys? We have to find the minimum and maximum possible values of C, okay? Rather difference. So what can happen? Can C be 2? See, the idea is that whenever you are given a problem, suppose there may be 5-6 people, okay? If I have a class 5-6 people over here who may not understand the problem, okay? In the sense, who may not know how to approach the problem. Why did we square? So what is the suggestion from my end to them? Don't panic, okay? So what you do is like you take examples. So it's like an adventure to you. I've always told you to all the people out here, when it's like exploring a new path, when you're in a forest or in an adventure, you have gone to adventures. So it's like you're exploring a new problem. So you should explore and see and take examples to explore the whole problem together. Okay. And then when you experience, then you know roads, and then you can take the roads. Or you can understand, okay, this is not the road to take. But when you're not experienced, take examples and explore. That's the beauty of problem solving. So take advantage of it without like thinking and Okay, and he's thinking too much about it and panicking. Okay, so if c is equal to 2, then a plus b is equal to 0 and a square plus b square is equal to 12. Can it happen? So can c is equal to 2 happen? That's my question. That is a plus b is equal to 2 and a square plus b square is equal to 8. Okay? So can there be a, so why? Tell me why it's not possible. It's not possible, it's simple. Okay, a plus b is equal to 0, yeah. It's simple because a plus b is equal to a is equal to minus b. You just replace it over here. You get that it's not actually possible. Okay, there is a is equal to minus b and you get, oh, a actually it's, is it possible? Let's see. That is twice a square is equal to 4. And therefore, a is equal to root 2 and b is equal to minus root 2. Am I doing it correctly? No, it's a, it be 2. So 2 plus 2, 2 minus 2 plus 2. And here it's 2 square plus 2 square plus 2 square. So it's coming up, right? 2 is possible. A plus b must be equal to 0. I'm so sorry for that. Yep. It's possible, right? So maximum possible of value of c is what? It can be 2 or not. It can be other thing also. So it's not positive numbers over here. So, yep. It's not possible. So it don't think that c is more than 2 or like cannot be more than 2. Okay, it can be more than 2 quite possibly. Okay. So, but how do we approach this problem? This is not the correct way to approach this problem, but this is for, I demonstrated for the purpose of people who may not know how to approach the problem. Okay. My question is that how do you approach the problem now? Kanishk was telling he is having a different approach. Sure. You can go ahead. Okay, so let's try it out. Okay, so what he's trying to do is that he's trying to express C in terms of A and B. Okay, so he's taking that twice minus C is equal to A plus B, and why not minimize A square plus B square? I didn't get your question, Shalini. Can you tell me once again? Why didn't we minimize? Okay, that's a nice approach. Kanish, go ahead. So all of you know Cauchy-Squart's inequality? A square plus B square into 2 is greater than equal to 1 plus 1 rather is greater than equal to A plus B square. So this is a result. Okay, if you see the book of Tito Andrescu, okay, all in mathematical Olympiad treasures, if you see the book and if you there are lots of equation solving problems, okay, system of equations problem. if you do those problems, you will see systematically the problems are based on inequalities. Okay, see, you have to understand this, that when you are given this problem, this is not in 3 variables and 2 variables are given, so they are not expecting you to do complex problems over here. They're expecting you to approach and do it in a very elegant manner. Okay, so inequality therefore helps over here. Yes, so if you apply a square plus b square, I will revise CS inequality soon. Okay, so a square plus b square is equal to into 1 plus 1 is equal to is greater than equal to a plus b whole square. Okay, if you do this, then what do you get? You get that a square plus b square is greater than equal to half into, that is a plus b 2 minus c square whole square. A square plus b square is essentially we are trying to bring down to equation in terms of c. Okay, or the inequality rather. Okay, so if you just solve it, it's 12 minus 2c square greater than equal to 4 plus c square minus 4c. Okay, let's try to do this problem now. 3c square minus 4c minus 20. Yes, you're right. Now we have to factorize it. So can someone tell me the factorization? So 3c square minus 4c minus 20. So it's a parabola, right? If you know about the parabola, it's a parabola, right? How does the parabola look like? Does it have a solution? So let's find its discriminant. Discriminant is what? It's 4 square minus, rather plus, so it's positive. Okay, it's positive. Discriminant is positive, so it has 2 roots. Therefore it looks like this. So where are the roots located? Can someone tell me? Did I do some mistake over here? Yeah. So 3c square. So we are trying to draw 3c square minus 4c minus 20. Okay. So let's try to understand this. Wavy curve method we can help in drawing the solution. Okay, so let's try to do a middle term factorization. Okay, so suppose we will apply rational root theorem. Suppose p by q is a root of this. Okay, then what do we know? We know that p must divide 3. Sorry, p must divide 20 and q must divide 3. Okay, so what are the possible solutions we can have? We can have, so let's write down the divisors of 20. 1, 2, let's take the positive 1, 2, 3, sorry, 4, 5 and 20, 10 and 20, and q is 1 and 3. So we have all these numbers by 1 by 3, 2 by 3, 4 by 3, lots of options. Okay, so that's a hit and trial method. So but we will first see the roots, integer roots. Okay, because it's there. Start with 1, so 3 minus 4, just tomato. Okay. 3 minus 4 will help. Okay, but essentially if you do the factorization, middle term factorization, it will turn out like this. 3c minus 10 is equal to c. So it's 3c square minus 10c. So 3c square minus 10c plus 6c minus 20. If you see this, it's all the same. So 3c minus 10 are both solutions, so it will be like this. We are doing middle term factorization. Someone has told it before, I guess. Yeah, Shambhav, it will do. Okay, so that's it. So yeah, So see how I was trying to do it in a very hard manner. So therefore we have got that we have 10 by 3 is a solution and minus 2 is a solution, the roots, okay? And therefore we have understood that ten by 3 and minus 2 are the solutions. So let's try to draw the diagram. Try to draw the diagram. 10 by 3 is here, minus 2 is over here, say. Yes, so essentially the graph must be like this. And C is less than A, the whole thing is less than or equal to 0. So that means what? C can at max be this here and this here, the roots. Okay. That is 10 by 3 and minus 2. The maximum is therefore the difference is 10 by 3 plus 2, that is 16 by 3. So that's the idea. All of you understood it? Any doubts? All of you understood these results, guys? Tishika, Ahana, Ayan, Manoj, Rajvardhan, Aryan Prakash, Sauratip, Olivia, Tisha, Sambhav. Okay, so that's the end of it today's class. Okay, so that's it. I hope the problem solving classes are going great. 3 to 4 problems are done every day. You should yourself solve problems. Okay, so see you in the next class, guys. And bye-bye. Yeah, so that's a good problem. A can be also have maximum and minimum, so you can find it out, yes. But it's symmetric in A and B, right? A, B, and C, right? So therefore, it's symmetric. Therefore, A, B, and C all have the same maximum and minimum range. That's a very good question, Rajvardhan. So observe that A, B, and C all have maximum and minimum range same because it's the whole equation is symmetric in A, B, and C. Okay? Okay. Bye bye. Good night, and see you in the next class. Hi Ashish. I hope you understood it. Okay. Bye bye. Have a good night ahead. Yeah, the T2 underscore book, just search on Olympiad, mathematical Olympiad treasures, okay? It's a T2 underscore book. Good night, Alpana.